Hello wonderful math learners. Today we have an equation, an exponential equation. Let's write the solution. We are told to solve for x in 9 to the power of x minus 6 to the power of x equal to 4 to the power of x. This is an exponential equation that has the same powers. The exponents are the same, but the bases are different. So we'll look at how can we ask ourselves one very important question. How can we make this basis to be related in a way that it will be easier for us to solve? Because exponential equations, when the bases are relatively the same, it will be very easy to find the exponent, especially in questions like this. If we break down these numbers individually, we can see that the number 9, which is the first number, is a combination of 3 multiplied by itself, which can be written as 3 squared. The second number 6 can also be written as the combination of 2 multiplied by 3. We'll leave it at this. The number 4, which is the third number, can be written as the combination of 2 multiplied by itself, which can still be written as 2 squared. We'll apply each of these, especially 9, we'll write it as 3 squared. 6, we'll write it as 2 times 3. 4, we'll write it as 2 squared. All this will change this form of this equation to make it easier for us. So notice how we'll do it. We said that if we write this equation 9/2, we said that 9 can be written as 3 squared all to the power of x minus 6 can be written as 2 times 3 all to the power of x equal to 4. We said can be written as 2 squared all to the power of x. We've not really solved anything. We rearrange this equation in a way that it will be easier for us to solve. So let's continue. There's a rule. An exponent rule that says if you are given a number, let's say a to the power of m all to the power of x, that it is the same thing as multiplying the exponents mx. So we're just saying that when you're given something like this, you can write it in this form. We'll look at this new form of our equation and see how we can relate this to this. So let's continue. Therefore, let's bring this down. We can write this as 3 to the power of 2x minus. When we look at this, let me highlight with another color. When we look at this very number, we can break it down as 2 different numbers. This is the same thing as saying 2 to the power of x multiplied by 3 to the power of x, all equal to 2 to the power of 2x. Let's break it down further. 3 to the power of 2x minus 2 to the power of x multiplied by 3 to the power of x, all equal to 2 to the power of 2x. It's still the same equation, just in a clearer form. The next step that we need to do is we need to move everything here to one side. So my recommendation is to move this 2 to the power of 2x to the left hand side and equate everything on the left hand side to be equal to 0. We now have 3 to the power of 2x minus 2 to the power of x, 3 to the power of x minus. Why it is minus is when positive numbers When a positive number or any number is crossing an equality sign, the value of the number changes. If it is positive, it will turn to negative. If it is negative, it will turn to positive. So in this case, this is a positive 2. Crossing over the equality sign will make it negative. This will now be minus 2 to the power of 2x. Will now equate everything to 0. If we look at this equation clearly, we'll see that one has 3 to the power of 2x and one has 2 to the power of x, 3 to the power of x, and the other is what? 2 to the power of 2x. The powers are now mixed, and that's a little bit of problem. So to fix this, we'll divide everything by 2 to the power of 2x. So our equation will now become 3 to the power of 2x divided by 2 to the power of 2x minus 2x multiplied by 3x divided by 2 to the power of 2x minus 2 to the power of 2x divided by 2 to the power of 2x, all equal to 0. There's an exponent rule that says if you have an exponent a to the power of n that is being divided by another exponent b to the power of n, as long as the exponents are the same, n, in this case, we can write this as a divided by b all to the same power. We will now apply this new rule to our original equation. We will replace all this in this form. The first, which is this, will now be written as 3 over 2 all to the same power, which is 2x, minus, let's pay attention to this second number. Here we'll do a little bit of math magic. It's not magic, it's just breaking it down clearly. Let's put it in parentheses. 2x multiplied by 3 to the power of x. Let's look at this denominator. When we look at this denominator, 2 to the power of 2x, we can break it down as 2 to the power of x because it is squared multiplied by itself, 2 to the power of x, minus, let's look at this, because they are the same power and the same base, so we can cancel out 2 to the power of 2x, can cancel 2 to the power of 2x. This will now be 1, because anything divided by itself is 1, all equal to 0. We'll continue to break this down further. Let's bring down the first number. 3 divided by 2 raised to power 2x minus. If we expand this, we have, this is the same thing as saying 2 to the power of x divided by 2 to the power of x multiplied by 3 to the power of x divided by 2 to the power of x minus 1 equal to 0. This will now be 3 over 2 all to the power of 2x minus 2 to the power of x divided by 2 to the power of x will give us 1, because it will cancel out. We'll be left with 3 this to the power of x over 2 to the power of x minus 1 equal to 0. We will apply this rule, this very rule, into this. It will now become 3 over 2 to the power of 2x minus, since they are of the same exponents, we'll group them, 3 over 2 all to the power of x minus 1 equal to 0. When we look at this expression, this equation, we can see that there is something that is repeating in this very expression on the left hand side, which is 3 over 2 to the power of x. We can still find it in the first number. So we can say let this very repeating number, which is 3 over 2 to the power of x, be equal to u. So when we substitute u into all this, we can see that this will now become this very one. When we put u to replace 3 over 2 to the power of x, we will have u squared minus, this is already u, it's the same thing with this, so we can say minus u minus 1 equal to 0. Now our equation has turned to quadratic. Let's solve this using quadratic equation. Our quadratic equation says that u is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. Our a is the coefficient of u squared, which is 1. Our b is the coefficient of u, which is negative 1. Our c is obviously negative 1, equal to negative 1. We'll substitute all this into our quadratic equation. It will now be u equal to b is negative 1. This is minus negative 1 plus or minus root of negative 1 squared minus 4 multiplied by a is 1 multiplied by negative 1. This will extend further to cover up all these things, all over 2 multiplied by 1 is negative times negative is 1, positive, plus or minus root of negative 1 squared is positive 1. Well, look at this bracket. This is positive 1 multiplied by negative 1 will give us negative 1. And this same negative 1 multiplied by negative 4 will give us positive 4. Therefore, this will now be plus 4 all over 2 multiplied by 1 is 2. Our u will become 1 plus or minus root of 5 over 2. Recall that we said that our u should be 3 over 2 to the power of x. Let's now bring back this u in form of 3 over 2 to the power of x in this equation. This will now be 3 over 2 all over x equal to 1 plus root of 5 all over 2. The reason why we are using the positive instead of the negative is because exponential equations are always positive. It's always easier to solve them as positive. So we choose the positive aspect of it. So that is 1 plus root 5 over 2. In order for us to solve this, the easier way is to apply logarithm. And there's a rule of log that says if you have log a to the power of x, this is the same thing as writing it in this form. This x will go here, it will now become x log a. We'll take the log of both sides and apply this rule. This is log 3 over 2 all to the power of x equal to log 1 plus root 5 over 2. Applying this logarithm rule here will give us x log 3 over 2 equal to log 1 plus root 5 over 2. We need to isolate this x. We'll divide both sides by log 3 over 2 in order to isolate the x. This will now become x log 3 over 2 divided by log 3 over 2 all equal to log 1 plus root 5 over 2 divided by log 3 over 2. This will cancel out this. We will now have x equal to log 1 plus root 5 over 2 divided by log 3 over 2. Another rule of logarithm says when you have a log a that is dividing b, we can express it as log a minus log b. If we apply this rule into this our equation, we will now have x equal to, for the numerator, log 1 plus root 5 minus log 2 divided by, we expand the denominator in the same way using this rule. It will be log 3 minus log 2. This can be our final answer for x, but we can still break it down further in decimal format. Log 1 plus root 5 is equal to, this is equal to, using our calculator, 0.51. Log 2, this log 2 is equal to 0.30. Log 3, this is equal to 0.48. If we substitute this into this, we have that our x will now be equal to log 1 plus root 5 is 0.51 minus log 2, we have it as 0.30 divided by log 3, we have it as 0.48 minus log 2 is 0.30. When we solve this, we have that our x, 0.51 minus 0.030 will give us 0.21 divided by 0.48 minus 0.30 will give us 0.18. If we divide this 0.21 divided by 0.18, we will have that our x will be 1.17 in decimal format. Let us check to see if this is correct. We'll bring down our original equation, which is, let's check. Our original equation is 9 to the power of x minus 6 to the power of x equal to 4 to the power of x. Let's see if we substitute this x into this left hand side, whether we are still going to get the same value as that on the right hand side. So we said that our x is equal to 1.17 minus 6 raised to power x is 1.17 equal to 4 to the power of 1.17. 9 to the power of 1.17 is same thing as 13.08 minus 6. This 6 to the power of 1.17 will give us 8.14. Will this give us 4 to the power of 1.17, which is 5.06? Let's subtract this and see whether we'll get the same thing. 13.08 minus 8.14. This is 4.06. 2.94. Approximately, because we approximated all these to 2 decimal places, we can now say that they are relatively the same by approximation. This is 5.06. This can be approximated to 5, and this can be approximated to 5. So we can say that our x is either in decimal place of 1.17, or our x can still be written as log 1 plus root 5 over 2 all over log 3 over 2. It depends on which format you want to use. In decimal format, it is like this. Without calculator, you can leave it as this. They are both the same and correct. If you enjoyed this episode, kindly click on the subscription button, the notification bell, so that you'll be notified when we drop the next episode.